hopefully you can see a slide. Oh, good. Thank you, Stephen, for nodding and thumbs up. Good. Thank you, Gianni. Right, we're going to talk about building HTML interfaces for NAO applications. I suppose the big question is, why would you bother? Well, the simple answer is NAO is basically the same as Pepper minus the tablet. And adding the tablet onto Pepper actually made it a lot more usable. Now, unfortunately, has never had the ability to have a tablet attached to its chest and be able to interact the way that Pepper does. And as we all know, if you happen to be in a slightly noisy environment or whatever, it can be a complete pain to get NAO to do things. So by having an interface that you can display, whether it's on a tablet or on a PC, or in the cases of the children that I work with in the schools where they have autism, they actually use big interactive screens on the wall. Yeah, they're basically massive Android tablets. So basically what we're going to talk about is we're going to be able to talk about creating an interface that will let you build an entire application with nothing actually in the behavior. But more importantly, it'll let you take an application you've got and build a supplementary interface to it, okay? So the example I've got, we're going to build an application where NAO can stand up, sit down and speak. Yeah, you'll be able to do all of that through a browser. And because I am literally going on holiday tomorrow morning, I haven't got a NAO with me. So I've got a video of the final thing that we create during this so that you can actually see it in action. I'm really hoping the video works over Zoom, but we'll find out. Yeah. So let's have a little think about what we're doing. Right, so our agenda, brief introduction. I just want to explain where this is coming from. A few prerequisites, that's the bit where I'm going to upset everybody, yeah. A little bit of the theory about how it works. Then we'll talk about a real life example. And then the conclusion is going to be seeing the video so that you can see what it actually does. And then there'll be a chance for you to ask questions and things like that. And you're going to see source code for all the HTML elements. You're going to see all of the choreograph stuff. So literally this is bare bones, everything that was done to build this app. And my first confession will be I nicked one of my existing apps and cut it down to do this, okay? But it enabled me to include some examples in the code which aren't used by this application, but we will talk about. Right, I am going to just hide those thumbnails for a minute. Right. The NAO Robots OS, NAOKey, actually has a built-in web server, okay? That web server is the web server that presents the configuration pages when you go to the IP address on your NAO and you log in. It also will serve any web pages and web applications that are stored in an HTML directory inside a choreograph behavior. And it allows for bidirectional communication between the interface and the robot. So that means that you can both update the web application because of what the robot's done, and you can update the robot based upon interaction with the web application. Yeah. This can be done with any JavaScript enabled browser. So that's Android phones, tablets, iPads, PCs, Mac browsers, you know, Chrome, Safari, all of those. And even as I mentioned before, for our autism solution, Assist, we actually use interactive wall-mounted displays. Okay, so so it's quite handy to have. Choreograph applications can really easily be added, the support for this, configured to support this. Basically, all you do is you create an HTML directory in the root of your application, and you dump everything that you want to be displayed on the tablet in that directory. Now, that's going to be your HTML files, it's going to be some JavaScript, and depending upon what you want to do with that interface, you may have other supporting frameworks. The interaction is actually provided through a JavaScript library that is built into the NAO OS that gives you access to every single API function call that's on NAO. That has a huge impact if you think about it, because it does mean you could, and I'm not suggesting you should, but you could write an entire application just in the HTML interface. Yeah. Right, let's talk about the skills you're going to need. And this is where I'm going to upset everybody, because I have a fairly strong belief, and I'm really hoping that Dave's either going to nod in agreement with me or shake his head in pure shock that I've said what I'm about to say. Unfortunately, I believe that Aldebaran were a little unfair to people that purchase their robots. Yeah, you can do a lot of stuff with the bog standard boxes that come with Choreograph. You know, I've been into schools and done a lot of work. We've got the kids building applications using the standard boxes, and they work really well. But to get the absolute most out of your NAO, you need to be a developer. You need to be able to write your own custom boxes. You need to be able to write your own applications, and you need to have a developer's mindset. Yeah. Subsequently, you're going to need to be able to do what we're going to talk about today. You're going to need to be able to understand HTML markup. Now, not a big deal, that one. Lots of people have written websites. There are loads of resources, both on the net and books that you can buy that will teach you that. You're going to need to understand JavaScript. Now, when I say JavaScript, I don't care whether it's bog standard JavaScript or it's whether one of the frameworks. I am a little bit of a Luddite because my favorite framework is still jQuery, because jQuery just works. I know lots of people talk about React and all the other wonderful frameworks that are out there. Personally, I like jQuery, yeah, probably because I understand it. And the other thing that you're going to need to have a really good understanding of is the NowKey API, yeah? Because basically you haven't got any IntelliHelp or guidance when you're writing the JavaScript. You need to know what you're doing, and when it goes wrong, you need to know where to find the errors, yeah? Other things that are really handy is you can't really write HTML these days without understanding a bit of CSS. For those of you that are not aware of what CSS is, that's cascading style sheets. That's basically what decides what color your text is and how pretty your website looks. Yeah. The other thing is, unlike Pepper, where we're developing to a standard size screen that never changes, you don't know if somebody's going to open your interface on a tablet, a phone, a wall-mounted display, you know, a PC with a browser, a Mac with a browser. They're all going to be different shapes and sizes, yeah? So you need to have something that will deal with that. And again, I'm a bit of a Luddite. I like the original Bootstrap stuff. So you will see in this example that I'm using some fairly old versions of Bootstrap and jQuery. I do that because NAO isn't the most powerful device in the world. So if I can achieve it with a slightly older version, it means that I'm saving myself some processor rather than some of the newer versions that do more. Yeah. Right, here's the theory of how it works. On your NAO robot, you have the NAO key OS. Choreograph talks to the NAO key OS. If you want to develop an HTML application layer over the top of that, you will use something called QI message. QI message has been wrapped in a JavaScript library, and that is what communicates between the interactions on your application and what actually happens on your robot. Yeah. And that would all be via a JavaScript enabled browser. So at this stage, it's just using HTTP and socket protocols. So no HTTPS or anything like that. So you're just dealing with a straightforward HTTP connection. Yeah. And the little picture that I've used over the top there is actually the assist application that we sell into schools, where they can use it on a tablet or on a big screen, and the teachers and the kids can interact with it independently. You will see when we get to the actual example that I've ripped that interface to pieces and we've taken some bits out of that make up our example. I'm just going to check everybody okay with where we are at the moment. I can see Dave and I've got a thumbs up from Dave. If there's anybody else that's struggling, let me know, either in chat or whatever, and we'll go back and cover anything that's not clear. Right, getting started. Create yourself a new project in Choreograph, okay? And immediately go in and update the manifest file and make the application ID something that you can remember. Now, when you do an application from scratch in Choreograph, it typically names the application whatever you want to call it, and then adds a stupid alphanumeric identifier onto the end of it. Yeah. 9 times out of 10, you can just take the alphanumeric indicator off the back. So you can see in my example here, we've got one with a silly alphanumeric on the end of it, and I've just taken it off. As soon as you've done that, save your project. It's really important you save your project at this point, because until you do that, your project doesn't exist as a file structure on the machine you're working on. We need to be able to access that file structure to build our HTML interface, okay? So, update your manifest, sensible application ID, save the project. You're going to be doing a lot of project saves in this, by the way, yeah? So save your project. The next thing to do is go in, hit the plus button and add a new folder and call it HTML, all lowercase. Yeah. That HTML folder, by having that in the behavior, whatever is in that folder will be served by the web server on NAO. So that's how we can actually make an interface come up. Yeah. And again, as soon as you've added that folder, save the project. Otherwise, the HTML directory won't exist on your PC. It'll only exist in the memory in Choreograph. Yeah. So just hit the save button. Yeah. So your interface, you can't build it in Choreograph. Choreograph doesn't have HTML JavaScript and CSS editors, and that's what we're going to be building our interface in. So you need to be happy with your favorite HTML come JavaScript editing environment. That could be something as simple as Notepad or as complex as Visual Studio from Microsoft or any of the other rapid development IDEs. I personally, as I mentioned, use jQuery and Bootstrap to simplify my build process. So you'll see those being used in the examples. You also really need to know how to use JavaScript to get this to work, because JavaScript's going to be creating the session to the robot and will call all of the NAO API calls that you use. And in your HTML file, you need to include the script that's detailed there, the QI messaging script. It's on every NAO, and it's actually on every pepper, all the Python peppers as well. Yeah. So you'll see in the code when we go through it, you'll see where I include that too. Right, the first thing that you need to do once you've included all those things into your HTML interface, in the JavaScript element, you need to create a session to the robot. Now, thankfully, because this is actually running all on the robot, you don't have to worry about specifying which robot or an IP address or anything like that. Yeah. All you need to do is create a session connection to the robot. And the piece of code that you can see there actually does it. Yep. That will create a session variable that we can use to create links to the SDK modules. So I'm sure you've all come across various modules like, AL text to speech, AL animated speech, AL memory. Well, all of those can be created, but we need a session to the robot to be able to do that. Once we've got that session module, we can actually create a link to one of the SDK modules. Yeah. So here's a very simple example. AL animated speech is actually a subset of AL text to speech. So you actually need to create a session to text to speech, and then inside that session, you need to create a session to AL animated speech. So what we actually do here is we just say, for our session, use the service AL text to speech. And once we've got the connection, the function speech actually creates the item that we're going to use. So I can then use speech dot and any function call that's in AL text to speech, and it will be actioned on the robot. For my animated speech, I create a second one. I happen to have called it TTS. Yeah. And then I can use any function call that's in AL animated speech. And we've got some examples of that. And all you've got at the bottom is just some failover code, so that if things don't connect properly, we know what's happened and we can write a console message. If you're lost, I'm not surprised, because this does get a little bit confusing on occasions, but it will become clearer when we look at the code. Oh, I managed to go up there rather than down. There are also two types of calls that you can make, yeah? And this one's probably a slightly better example than the text to speech. There's an SDK module called AL Robot Posture. And it's a bit of a cheap one, because it will let you do things like tell the robot to stand up and sit down and things like that, just using a single call. So here you can see that using the session that we created originally, I create a call or I create a reference to the AL robot posture module, and that happens to be called posture. For those of you who are not familiar with jQuery, where it says $ open bracket hash stand up close bracket, yeah, that's basically identifying an element in our HTML file that has an ID called stand up. So in our case, it's an image button type element, so that when I click on it, hence the dot click, I call posture, and then the function call go to posture, and there's a predefined posture called stand, and the 1.0 just says do it in your own time. You can actually control the timing on them, but you're best just to let it do it in its own time. That way you won't hit any problems with the animations. The other type of call is what's called a subscriber call. For those of you, I suppose I should ask the question really, let's pop you all back up. How many of you have looked at AL memory? Oh, good. I've got 2 at least. Yeah. Thanks, Gianni. AL memories, for me, is one of the most interesting modules that's in the SDK, because AL memory lets you store data locally on the robot, and it also lets you raise events on the robot so that you can create event-driven programs. Yeah. So AL memory is pretty interesting. And one of the things we'll look at is how you can raise an event from your HTML interface. But the example that we've got here on the screen is actually reading a value that might be changed by the robot. So in our example, we have got a session to AL memory, and then we have subscribed to an event that is generated by NAO's operating system. The event is called battery power plugged changed. As you can imagine, that event is raised whenever you plug in or unplug your charger from the back of NAO. Now, we've subscribed to that event. Unfortunately, the subscriber signal isn't a really nice, clean one. So they have provided us with this signal connect function that allows us to return a more usable variable from the function call. So what you can see here is I subscribe to the function, and it returns me a subscriber object. And then when I do a signal connect, the function, the event, when it changes, actually passes me back a state. And that state is either a true or a false. Yeah. So it tells you whether it's plugged in or whether it's unplugged. And then I've got a little bit of code in a function called battery charging, which just updates my interface. So on my interface, I put a little lightning bolt next to the battery level in my HTML interface if it's plugged in, and if I unplug it, that lightning bolt disappears. The 3 little dots is just there to turn around and say to you that there was a lot more code in this section. So that's not a complete piece of code, it's just a snippet. We'll look at the complete code in a minute. In fact, we'll look at the complete code now. Let me see if I can share my Visual Studio. Right, I'm going to again pop up so that I can see people. Can you see code on your screens? Yes, good, excellent. Right. So I'm just going to pop up a piece to one side here. Let's pop you all over there. I'm going to pop up the Solution Explorer. Now, I happen to be using Visual Studio, but that HTML that you can see at the top of the solution is actually the HTML folder inside a choreographed behavior. And I happen to have some CSS and some font stuff. It's actually Font Awesome that lets me do natty little icons on my interface. So Font Awesome, if you're doing this sort of stuff, is useful to use. My battery charging level, I only do it in 25%. So, you know, a fully charged battery is all white, and then it cuts back in 4 levels. Font Awesome have icons for all of that. As I mentioned, I use Bootstrap for the various sizes. So you can see that we've got Bootstrap here. We'll talk about fast click a bit later when we look at the code. I've got some height matching stuff, but basically they're all supporting. The only 2 pieces that are really important here is the HTML page and the JavaScript functions that I happen to have called adaptive2.js. So let's have a look at the HTML to start with. Fairly standard stuff, yeah. All of the first part of this is all just very standard bits and pieces that just make sure it works on various tablets and browsers. And then I just load all my CSS stuff. The next piece defines what my interface looks like. And what I'll do is I'll get rid of that sidebar so we've got a bit more script. So this just defines the element. So my interface has a stand up button and a sit down button. So you can see we've got an ID stand up and an ID sit down. They're images, so they literally have the word stand up and sit down underneath them. So that just gives us a way that we can have something on the user interface that can be clicked. Yeah. Across the bottom of that, I've then got a volume control, which we'll be able to see working when you run this on there. Basically, it's just a horizontal slider that lets you change the volume. And when you first load the interface, it queries your NAO to see what the volume is set to. And then when you slide the slider, it adjusts the volume on your robot to make that appropriate to what you've set it. Yep. You can see I've got a little battery charging icon that we update as well, just so that we know what the battery level is and whether it's being charged. And then underneath that, we've just got a very simple say box. Yeah. So what we've got is we've got a text box that I can type in something that I want the robot to say, and I've got a button that I can click to make him say it. All right. Underneath that, we get the interesting bits. I'll highlight the bits that are actually important. There is my inclusion of the QI messaging JavaScript library. That's the library that exists on every NAO and every Python Pepper. On newer NAOs, the version 6, and on the Python Peppers, that's now version 2. So it's 2.0.qi/QI messaging.js, not 1.0. On version 4 and 5 NAOs, it's still at version 1. Basically, it makes virtually no difference. Certainly doesn't change the way that you do anything. Yeah. I've then got my supporting bits. I said I would mention fast click. Yeah. I'm sure Dave's probably come across fast click. Fast click is just a library that deals with something that's built into tablet browsers. Because tablet browsers don't have the ability to do things like hover over an item and stuff like that easily, fast click deals with the delay that's built into a tablet browser. So it's ignored if you're working on a PC, but if you're on a tablet, you can get this delay when you click a button before something happens. And fast click is a way, is a library that just eliminates that that delay. Yeah. And then the other file that we're going to look at is my JavaScript file, which has got all of my actual real interface to NAO and to the NAO key SDK. Right, let's have a look at that. Hopefully, having seen that, it'll become a little bit clearer. So we've already loaded the QI message JavaScript library. We did that in our HTML page. The wonderful thing, one of the reasons I like jQuery is jQuery has a thing called the document ready function. So what it does is it basically loads everything in your HTML page. And once it's loaded everything, it goes, that document's ready. And at that point, it runs my code. Okay. That means I don't have to worry about my code loading before a library like QI message has been loaded. I know everything in my page will be loaded before it runs. So the first thing I do is I create a variable called session, and that is a new QI session. So that uses the QI messaging library and creates a session object. That session object at that point is empty. Okay, it's just an instance of the object. I create a couple of other variables. You can see I default the volume to 50 until it reads it from the robot. And I am using a couple of tooltips. So I just load some tooltip stuff, which just activates the tooltips. That's particularly useful on Android tablets and in browsers, because if you float over the top of the battery icon or tap the battery icon on a tablet, it will actually pop up the actual charge value. So if you're at 80%, you might have 3 bars on the icon. If you tap it, it'll pop up a little tooltip and tell you exactly what percentage charge you have, okay? Doesn't work on iPads. I don't know what it is with the Safari browser, but the Safari browser on an iPad will not do the tooltips, yeah? But hey, I mentioned fast click. Fast click's just attached to my entire body of my document to make sure anything I tap reacts without any delay. Now, using the session object that I've created here, I actually now create my connection to the robot. Okay. So once that connection is created, basically I've got an active connection between my browser and the robot. And you'll notice that there's no need for me to specify the IP of the robot or anything else, because the web server is running on NAO. It already knows what we're connecting to. Yeah. So the session group just goes, oh, I'm running on this robot. That's what I'm connecting to. Little function call here. We'll come back to this one in a minute. And we'll come back to this one in a minute as well, because I've got an example which uses these two function calls. Here is the way that we get NAO to speak. Okay, this piece of code. So I have an input box which has an ID of say input box. Yeah. So if I click on the hash say element, which is my button, my say button, it reads whatever value has been typed into the say input box, and it sends it off to my say function. So it says TTS say. Well, TTS, as you can see, as you can see here, is actually my interface to animated say. So all I do is I pass that object and what I want said, and we go back up the screen a little bit. And there's a function call which takes my object, takes the text. Because this is an object to animated say, I call the say function that's in the NAO SDK and pass it the text that I want NAO to say, and NAO speaks. It really is that easy. The hardest part of this is getting your interface to look nice and making sure that when you click a button, it actually gets picked up by the JavaScript. Yeah. Let's come down and look at a couple of other bits. Here's the bit for standing up and sitting down. So I create, using my session object, I connect to the AL robot posture module, and I call it posture. If somebody clicks the stand up button, I call AL robot posture dot go to posture stand, and it stands up. If they click the sit down, I call AL robot posture, go to posture, sit. So posture, so this posture that's created here is just a proxy to AL robot posture. It's our instance of it that lets us call the function calls. Here's the volume stuff, yeah? So I connect to AL audio device. My proxy is called audio. So when this first runs, the first thing it does is it says, right, use AL audio device, go and get the output volume that's set on now, return it as volume. So it will return us a number between 0 and 100. And then all I do is I update a couple of elements. So the hash volume element is my slider. So I tell it where to go. I've already set my slider up to be from 0 to 100. So if I read that it's set to 80 on the robot, my slider will go to 80% of its travel. Yeah. I also then pass that value to another element that's tacked onto the end of that, which shows numerically what the value is. You'll see that when we look at the interface in a little while. Yeah. Now, of course, the other thing that I've got to do is I've got to deal with what happens when I move the slider on the HTML interface to actually sort out the volume on now. So my slider is called volume. So I say, well, when there's some input on that, what I do is I read the value that's been set on the slider. If it doesn't equal the volume that we already have, so, you know, if somebody's touched the slider but not changed the volume, we don't need to worry about it. If the volume's changed, I read the new volume. I set the volume on the robot. So again, using my audio proxy to AL audio device, I call the function called set output volume and pass it the integer of whatever that value is. And then I also update the value on my next to my slider. Yeah. If any of you download the example, you'll be able to see that as you move the slider up and down, the numbers change. And if NAO's talking, his volume will go up and down as well. Yeah. Right. AL memory. I've included two versions, the wrong version and the right version. It doesn't cause an error, it just doesn't work. This was the old way of doing it, yeah? Which was basically we create a proxy to memory, we say get the data for this and change it, yeah? Same here. It didn't cover the fact that they changed the format of the data coming back, and you need this subscriber signal connect so that you can get meaningful information back from it. So here all we're doing is we're using AL memory. We're subscribing to the event battery power plugged changed. And when it changes, we're grabbing the state and processing that in some way. Yeah. In our case, we're putting up a little lightning bolt next to the battery icon. And then here we've got the one for the actual change in state. So as the battery charges, the battery charge changed event is fired. And that contains a value from 0 to 100% to tell you how charged up the battery is. Yeah. And here's the function calls that we were playing around with. So you can see here that all this does is, so our battery change, yeah, which is used by, you know, how much it is, it just goes through here and it says, oh, if the battery's over 90%, it's fully charged. If the battery is greater than 75%, give it 3 bars, give it 2 bars, give it 1 bar. These FA battery -1, they're part of Font Awesome, which is an icon set of, well, thousands of icons, which you can very, very easily use on web pages. If you're doing any web development, well worth a look. Yeah. And here's a FA bolt. Yeah, so Font Awesome lightning bolt. And it's just adding or removing that class so that we can display whether or not it's charging. Yeah. Fix heights, just something I use to keep images the same size in case somebody sticks an image that's a different size in there for a button or something. Fix heights just allows us to match heights on images that are being loaded. It was really, really useful when we did the assist application, because people can upload their own images in Choreograph for the picture that's shown for the application, and Choreograph doesn't change the size of those images. So some people were loading up 500 by 500 pixel images. Some people were loading up 250 by 250 or whatever it happened to be. Yeah. What we were able to do was we're able to actually read the icon they've loaded through Assist, but we didn't want our interface to have all sorts of different sized icons, pictures for the applications. So by using fixed heights, we were able to get a common size for all of the applications. The only thing we asked people to do was make sure that the image that they uploaded was square. Yeah, that way we had nice square icons, all the same size on our interface, which was the one that you saw on the slide saying how all of this technology worked. And that's it. I mean, this is a pretty effective application in 155 lines of code with all of my really, really bad coding. I'm sure there are better ways to do it. Yeah. So it just gives you a feel for how we're building this JavaScript interface. I am now going to attempt to change back. Hopefully we've got the, let's look at some code slide in front of you again. Please wave, Dave, if it is. Yay, it's good. Right. So once you've built this application, obviously it won't pop up on the tablet magically itself. You have to actually tell the tablet to go to it. So it means that you tend to build applications when the application runs now doesn't do anything. Then you load the web interface, and that lets you trigger off what you want him to do. And the way that you do that is in your browser. You just go to the website, which is your robot's IP address /apps/ and the behavior ID. Now, hopefully you can see why I was asking people to take away the silly numbers on the end of the behavior ID, the application ID, because you're never going to remember those, but you'll remember now HTML example or assist or whatever you've called your application. So then you can just go, and the example, this was actually the robot that I was running this on in my office, was at 192.168.0.37, apps, now HTML example. Up pops my interface as soon as I do that, yeah? And by the way, if you are really, really clever, like Luke, who used to work for me, you can actually access the HTML interface and have that start the underlying behavior, because the HTML interface will be served regardless of whether the application is running. So Luke had a really, really neat little routine that we used in Assist, that if a teacher picked up their tablet and went to the Assist teachers page, it started the Assist behavior on NAO underneath. So they never had to run the behavior. They just went to the web interface and the behavior ran automatically, yeah? Again, really, really useful to keep it simple if you're actually dealing with non-technical type users. So what you're getting here is, this is actually the interface that you're going to get all the source code for, yeah? So we've got a stand up and a sit down button. So if I click stand up, now we'll stand up. If I click sit down, now we'll sit down. There's my volume slider, so I can adjust my volume. If I float over the top of my battery, and my battery was fully charged when I took this screenshot, you know, if it was half charged, it'd only be half full of white. If I float over the top of it, it would tell me exactly what the battery charge is. And then I can type some text into my text box here, hit the say button, and now I'll speak it. Yeah. I do not know if this is going to work. Perhaps, Dave, you can tell me if it's a complete disaster. Yeah. But here is a short video of that application being run yesterday when I finished the presentation. Okay, so we're going to give this a go. Hopefully this will work. There you can see my NAO, and there is our application. So what we'll do is we'll get NAO to stand up. So there he is, as you saw, he stood up. Now if we come back to the application, you can see I've already put in a phrase for him to speak. So we'll hit the say button.
Hello everyone.
And there you go, you heard him speak. And now I'll get him to sit down. And that's it, an application that uses an HTML interface. Right, there's one thing that I'm going to say about that video. I had to hit the stand up button twice because I had that tablet on one of those stupid flexible arms. And the first time I hit it, I didn't hit it hard enough and the tablet just moved away from me. So the reason that you see me in the video tap that twice is just the fact that that it didn't register the click first. I will put this presentation in the links up on RoboHack, and we'll link it through to the NAO user group. For anybody who wants the source code, that's the link to it on Dropbox. What I want to do though is just show you one other thing. So let me do a new share. I want to show you the choreograph behavior. That's the choreograph behavior. What you'll notice is there are 0 boxes in it. Every single function that you saw in that video is called using the proxies on in the JavaScript. So I actually don't need any boxes at all on now. Having said that, there is another way that I can do it. I mentioned that we would go back to a function call in here. There is a function call here called raise micro event. Yeah. Now, raise micro event just lets me put a piece of data into AL memory. Yeah. So I would have to call raise micro event from inside our memory proxy. So I'll call it here. So where I've got example raise micro event, what I'd actually do, and I'm going to grab that bit of code there. What I would actually write into my code would be the following. I would go raise micro event. Now our proxy to AL memory is called memory. So our event object is that proxy. So that becomes memory. I'm going to create my own key name. I shall call it stand up for me. And I shall send it a value of 1. So basically what we're saying here is that with the click of a button or whatever it happens to be, we could call that piece of code and it would pass into memory a memory event called stand up for me. And that memory event would have a value of 1, but it would actually raise an event for it. I'm going to open up the look of you. How many people have played around with events in Choreograph? I know Dave has. I'm glad Stephen has. I know Gianni's had a little bit of a play with them from the conversations that we've had in the past. Yeah. Let's switch back to Choreograph and imagine that I've got that being called on a click. Yeah. So let's drop back to Choreograph. Right. Hopefully you can see Choreograph. Unfortunately, it might not be very clear here, but there is a little blue circle with a plus on it at the side of our build. Yeah. If I click that, I can add a new key. My new key will be called stand up for me. Okay. So I can do that and I can okay it and I get one of these funny little whizzy boxes appear. Yeah. And it's basically a connection to an event. So that will fire when an event is raised on that memory location. So the little piece of JavaScript that I had there. So I can now find my stand up box and I can just connect that event to a stand up box. So now if in my JavaScript, I call raise micro event and I happen to pass it the key name of stand up for me and a value of 1, it will fire that event. Now, at the moment, I'm ignoring the value, but I need to pass a value. Yeah. If you wanted to pass some sensible, meaningful data, you could do that. You know, your web interface could include logging how long somebody spent doing a particular function on there. We do that with the autistic kids. You know, they'll start an activity and we'll actually record how long they interact with the robot. And then when they finish the activity, we send that value back and record it on the robot. Yeah. So that data is available. So there are a number of ways you can do this. You can directly call all the different API calls you want to. I don't tend to do it that way. I do sometimes. Or you can raise events and bring up all the different bits and pieces. On Pepper, we tend to do it event driven. The other one is there's a function called, I'm pretty sure a few of you have played around with dialogue. I know Gianni has, I'm pretty sure you have, Stephen, yeah? One of the really interesting things is that one of the problems you can have is if you've got an interface with buttons on it, yeah, say I've got an application where NAO's taking a coffee order. So the first thing he says to me is, what sort of coffee do you want? Do you want a latte, a cappuccino, a mocha, or an Americano? Yeah. Now, it's being run by dialogue. So if I say latte, it just picks up latte as a word and goes, yeah, I know how to respond to that in my dialogue. The problem is do I want to write a second set of code so that when I tap latte on the tablet, it does the same thing? Yeah. Well, I don't. So there is actually a function call in the dialogue API that lets you force a text response into the dialogue conversation. So that means you can write an interface. You can have just one dialogue for my coffee ordering, and he can say, do you want latte, cappuccino, mocha, Americano? And if I tap the tablet and say latte, instead of passing that back as an event, using the dialogue force input function, now thinks I spoke it. So my dialogue's managed. Yeah. Again, really, really useful in noisy environments. Yeah. And I certainly know Gianni has looked at an app that I've got on Pepper called the Wine Selector, where it asks you lots of questions about the things that you like to eat and drink and that, and then it recommends a wine. Yeah. Well, that's written using that false dialogue approach because the whole thing is driven by a dialogue. And I didn't want to write two lots of code for it. So all we do is the web interface forces the data into the dialogue. And if you start playing around with this, have a look, particularly if you like dialogues. I really like dialogue. I think it's really useful. But if you want to put a web interface on it, have a look at the false dialogue input because it's really, really useful. Right. And on that note, I am going to shut up. I hope that was useful. If you've got any questions, please feel free to fire away.